Alright, in the next couple of lectures I will be discussing the specifiers for the U properties and the U functions. Once we work through a couple of examples on those, I will summarize those for you. So I will not be discussing everything in this lecture, I will not be discussing everything relating to the U property. Alright, to get started I have the project open in Visual Studio. I do not have the editor open because we can get some strange behavior with the live coding, which I will demonstrate in an upcoming section. But to get started, in the dummy actor we already have this class created, dummyActor.h, or you can create a new actor if you want. I will go ahead and create a float. Now from the previous examples we have this here. Alright, so I want a U property, which I will name x. And basically what we want to do for this first example is we just want to get oriented and we want to just do some basic calculations and we want to look at some of the specifiers that go in here. To get started we will create three variables x, y and then x plus y because we want to do some addition. We want to enter some values in the editor in those fields in the details panel, and then when we click play we want to do a calculation to get the result of that addition. So I will select this here. Alright, we have these three floats now, x, y and then x plus y. I've also initialized those to 0. Of course, I prefer to do that in the constructor, in the initialization list. Okay. But for this example, I will keep it simple. Since we do not have any components or anything yet, I will keep it simple and I will initialize that right here. I'm also doing this in the public section for right now. I will talk more about that as we go along. But these won't show up in the editor at the moment. So I'll actually just build a run and show you what I mean. Alright, back in the editor, in the content browser, I will navigate to the C++ classes, C++ experiments. And we can drag in that dummy actor into our world. Notice a couple of things with that dummy actor selected in the outliner. You may have to search for that if you have something else selected. Or if you deselect something, again just find that in the outliner. Right. Notice that we do not get those variables x, y and x plus y in the details panel. This is an actor, so it can exist within our world, but currently it does not have a transform. So it actually draws its transform, its position, its rotation and its scale from a component. For example, I can add some component to that, such as the cube. That is now basically going to be the root component for this actor. Now if I go to all, we will have the location, rotation and scale. If I double click on that now, we can actually frame up on this. Whereas with that cube selected, if I delete that component, it's actually going to generate a default scene root. And you can try and delete that, that won't actually delete. So what I'll do is I'll delete that dummy actor instance in the world, select that in the outline and delete that, and then just navigate around a bit. Back in the content browser, I'll drag another instance of that in. Again, we do not have a transform. If I double click on it in the outline or press F in the viewport to frame up on that, I cannot frame up on that because it does not have that transform. But also notice that I'll just go back here to the content browser, all under content, and I will create a new folder here. Just this one folder here where we will add our blueprints. Because in some of the other folders you may have more specific blueprints that relate maybe to the first person and so forth. So we want to create this higher level blueprints folder. And then back in CPP experiments, I will right click on the dummy actor and I will create a blueprint class based on dummy actor. Put it in that folder. I will name that pp underscore dummy actor and I will create that. Close off that content browser. Notice that by default, this has a default scene root. Whereas the C++ one that we've dragged into the world does not have a default scene root. Of course, as I mentioned, you can add one here. You can add a scene component or something like that. Or you can add a cube if you want a static mesh as the root component. So I have a default scene root. And if I compile and save, drag an instance of that in, of course we have the transform show up. Now we have location, rotation, which we do not have again with the C++ one because that does not have a scene root. And what we can also do is we can add maybe a cube, for example, or some other static mesh component. And now what I can do is I can left click and drag and I can drop that on the default scene root. To make that cube static mesh component the new root, the default root will be deleted in this case, so I'll just go ahead and do that, and notice that this is now the root. If I should decide to delete this here, this static mesh component, select that and delete that, notice that it's going to revert to this default scene root, so it's going to basically add a default scene root back again. So I just wanted to demonstrate the differences, what we get with the C++ by default and what we get with the blueprint by default. By default, the blueprint will have some root, whereas it is not necessarily the case with our C++ classes. And I will discuss how we can add components in C++ in an upcoming lecture, but first we want to discuss the specifiers for the UPROPERTY and the U function as I mentioned. For right now, we are not concerned with the fact that we do not have a transform for our dummy actor, which is in the world here. I'll just go ahead and save all. So we have our dummy actor and our blueprint underscore dummy actor instances in our world now. And once again, I'll just close off the editor for right now. Go back to Visual Studio. Now we need to think about what it is that we want to do. We want these to be editable in the editor, so in the details panel, and they need to show up, of course. And then this one down here, x plus y, only needs to be visible. We don't need to edit that, we only want to see what the output is going to be once we hit play. For that we can use some specifiers. And actually I'll show you a quick trick here. If I right click on this and we can pick definition or go to definition. Here we have a UPROPERTY. And if we scroll down, we actually have this enumeration, which is the valid keyword for the uClass macro, for example. And then if we continue to scroll down, we have valid keywords for UI interface. And here we have the valid keywords for uFunction and uDelocate macros. Again, scrolling down. Finally, we have the valid keywords for the UPROPERTY macro, alright? Sometimes they change these files and sort of where things are located, so it's best to maybe keep a note on these instead of relying on this file each time. And it's also a bunch of scrolling that you have to do, but in any case, of course you can always search for this, so you can do Ctrl F and then type in UPROPERTY to find this faster. Alright, but you have a bunch of these, and I'll scroll down a bit, and what we want to do is we want to edit. Here we have edit anywhere. This indicates that this property can be edited by property windows, in the editor, and so on. Then we have edit instance only. We only want to edit this on instances, not on arts types. Then we have edit defaults only. This property can be edited by property windows, but only on arts types. For example, in our blueprint dummy actor class, we can edit the defaults for that, but not on an instance basis. Then we have this visible anywhere. This property is visible in property windows but cannot be edited at all. And then something similar, as you may expect, you have visible instance only, and you have visible defaults only, and so forth. We'll discuss some of the other ones as we go along. Basically, you have two keywords. Do you want this to be editable, or do you want this to be visible? At this point, we are not concerned with editing or fetching these values from the blueprint editor. That is, from the graph, we simply want the defaults to either show up and be editable or be visible. So we have those two keywords, edit or visible. We want x and y to be editable. But we don't want x plus y to be editable, we just want that to be visible. To get started, we will do edit anywhere and visible anywhere. Next, we want to do that calculation x plus y and then save the result in x plus y. When should that calculation happen? Well, when we click play, we want that calculation to happen and store that value in x plus y. So let's go to the dummy actor CPP source file. And here we have the begin play function. We will talk about tick a bit later on. And also, of course, this is the constructor. This has the can ever tick. So in other words, will the actor call the tick function every frame? We can set that there. Here is the tick function. This is called every frame. Again, we'll talk about this in a bit more detail later. Notice that many of our functions will have the super and then begin play, for example, and in tick we have super tick. That is going to call the parents version of that function. The parent class may have some additional functionality that we want to have invoked. Following that, we will do error code. All we need is the simple statement x plus y is x plus y. And with that, I will build a run again. Now if we select our dummy actor in the outliner, this does not have a custom section yet, so the variables x, y, and x plus y will actually show up under dummy actor, which is the name of our class, split up like that. We have other categories as well, such as rendering, replication, and so forth. I will discuss how we can set up our custom categories so we can create a specially named category. I will discuss that a bit later on here, but for right now it should show up under dummy actor. I will set x and y. I will set x to 2 and I will set y to 4. And now of course we have x plus y. Notice that we cannot left click and edit this. X and y we can edit because those are editable. So again we can add values in there, but x plus y is not editable, but it is visible. And actually I'll just simulate this. Simulate. And now that value will change. We will get 6 in there. Might be a bit difficult to see, so I'll change the first one, x, I will change to 3. And then if I click simulate again, notice that x plus y is 7. You may also notice that the editor will separate out some of your words, such as you will get x plus space and then y, and then similar for dummy actor, we have dummy space actor, not dummy actor, close up without the space, we actually get the space. Because of course our variable names cannot have spaces, so this makes it easier to read by adding spaces for us automatically. We'll stop that. Also notice that we have the revert option, or basically reset, which will reset to the default. The default is what we have set in the C++, which is 0. So if I click this to revert that, it's going to revert back to 0. Alright. Edit Anywhere allows us to edit that UPROPERTY within the details panel here. This is on a per instance basis, because we have these instances in our world, which are in the outline, of course. The blueprint of dummy actor will not be set currently because we have not set that. We can set that in here, as you can see. 4, 3 for example, and we can click simulate and x plus y will be calculated and we will show up. But we can also open that up, so I will go to the content browser under blueprints and open that blueprint up again. Now under the class default section, we can see we have the dummy actor. Under the dummy actor category, that again will be the default category for these variables because we do not have a custom category set up for those yet. So we can set that here as well. So not just on an instance basis, but also the class default. So we can change those to 3, for example, 4. Notice that we get the revert button again because the default for these variables are 0. Also notice that we cannot edit x plus y. It is also only visible within the class default for this inherited class. Now I will compile and save. So with that compiled and saved, I can now go out of that. And if I simulate with that blueprint selected, if we try and revert those now, those will now revert to what we have set up for the blueprint by default, as opposed to what we have set up in the C++ file, so in the constructor or wherever we set those up. Go and revert those and we can change those. Click play and it will do the calculation. One more demonstration before we move on. I will close this off, save everything, and then back in the header file, I mentioned we can do instance only, and we can do defaults only. So for x we can only edit the value on a per instance basis, but for y we can edit that in the defaults only, and then of course x plus y will remain visible anywhere. Save that and let's check out what we get now. For the dummy actor, again that is the C++ class that we have instantiated, we can only see x, we can only edit x, which remember is edit instance only, so we do not even see the y variable, that does not even show up. But we can still edit x, and then for the blueprint, open up that blueprint again. Notice that in the class defaults only y shows up, x does not show up, and then x plus y of course is still visible, but y is only editable in the class defaults, whereas the x is editable on an instance basis. So I'll go to the blueprint, dummy actor, instance. Also notice here under the dummy actor section, x is editable. So I'll do something like 5 for example, You may notice something strange happens when I click simulate now. We actually get 10, that is in x plus y. As an exercise, pause the video for a second and think about why that is. Don't let these things catch you out. So previously we had, I'll just select dummy actor here for example, we had y set to 4, so 3 plus 4 is going to give us 7. If I simulate that, we get 7. That is with the C++ instance, but then we also have an instance of the blueprint derived class, and with that y was set to 5. In the dummy actor section, if I set that maybe to, if I set x to 8 for example, and I simulate, now we get 13. So again, don't let these things catch you out. We have the blueprint dummy actor instance, and then we have the dummy actor instance that is an instance of the C++ class. Those settings will persist, even though we made some changes in the C++ side of things. We have made changes on a per instance basis to the state of those instances. For that reason, we can go ahead and delete these. If we drag in a new instance, of that. And also under blueprints, I'll drag in an instance of that. Now those will be reverted. So if I select the C++ instance, x will be set to 0 because that is in the constructor for that. Again, if I simulate, x plus y will be 0 and x will be 0 as well. But for the blueprint, x will be initialized to 3 because that is set in the class default. But notice once more that that doesn't show up, and that is because we have modified the visibility of that in the C++ side of things. Okay, back in Visual Studio, remember that we made this edit instance only, that is for x, and then edit defaults only for y. Edit defaults only will mean that that will only show up in the class defaults right here. Edit instance only will mean that it will show up on a per instance basis as we have it for x right here. I'll set this back to edit anywhere and I'll build one final time. That is for this lecture. When you open up the editor, you may get a pop-up like this. Click open. Or what you can do is, if you search for that, what you can do is you can open up the blueprint editor, so I'll just close that off. You can edit that blueprint by clicking right here in the outliner, instead of having to find that in the content browser as I had done before. Alright, so you can see right here actually under dummy actor, this is the class defaults, or you can click on open to view the full thing. And again, under the class defaults, under dummy actor, we have x and y now shows up. This is the defaults that we had set previously, but because we had made changes to the C++ side of things, that one variable x did not show up, even though we had modified that for the class default. So now we can revert that, compile and save, and now with that instance selected in the viewport, the default is now back to 0, 0 for x and y respectively. So of course these are instances of those classes, the C++ and the blueprint classes respectively, and you can have many instances of that by dragging in that from the content browser or by spawning them from blueprint code for example, or from C++ code. You can also spawn stuff from C++ as I will demonstrate in a future lecture. And now you can see in the outline we have multiple instances of the C++ class spawned in your level, and also multiple instances of the blueprint class spawned in your level, and each one of those can have their own state. So for example, x here on this one we can set to 5. On this one right here we can set y to something else, 4 for example, and so forth. So each one of those can have their own state. Okay, back in Visual Studio, for the most part we will be using edit anywhere and visible anywhere, as opposed to visible defaults only, visible instance only, edit defaults only, and edit instance only. We prefer to use edit anywhere and visible anywhere. So don't worry about the other ones too much, those are more situational. These are the important ones to remember. Again, edit anywhere and visible anywhere. Those are the specifiers that relate to the editor accessibility and visibility. Now let's jump back to the editor, go back to the blueprint. How can we make some of those variables such as x or y or x plus y show up in the blueprint graph here? And also here to the left, this is basically similar to the header, that header file in C++, and this one right here in the center in the event graph, This is similar to the source file or the implementation, the .cpp file. The question is, how do we get or set our variables within this graph right here, and maybe have those show up in the left tab here so we can get easy access to those, so we can drag and drop those in to get and set those. Well, for that we have specifiers as well, specifiers for blueprint accessibility, and we will discuss that in an upcoming lecture. But for now I'm going to wrap up this lecture. I'll see you next time.